So the first pattern that we talk about is what's called the square of a binomial. Remember, a binomial has two terms, and we are squaring it. Now, remember though, whenever you square something, you're just taking it times by itself, right? So this is really just saying, okay, take a plus b and times it by itself, a plus b. Now from here, you would either FOIL or double distribute, but what I really want to emphasize is you cannot take a look at your, a plus b squared and just distribute that. You cannot do that. You have to FOIL it. Because think about it, when you end up FOILing, you get this middle term that just wouldn't exist if you just tried to distribute. Okay, and the same thing is possible, or the same thing is true, I guess, when you are subtracting in between. There's nothing super special about that, but just do not try to distribute that. So in example 1, when we want to multiply that, well, we're squaring it, which just means we're taking it times by itself. 2x minus 3 times 2x minus 3. And I have two ways that I can multiply this out. I can FOIL or I can double distribute. For this first one, I will FOIL. For the next one, I'll double distribute. It makes no difference. But if we, what did I just say? I'm going to FOIL this one? Now I can't remember. Well, I'll FOIL this one. So F, O, I, and L. So F stands for firsts. Our two firsts are 2x times 2x. Well, the 2 times the 2 is a 4. X times x is going to be x squared. O stands for outside. So 2x times, don't forget that sign, negative 3 will give us a negative 6x. I is our insides, and interestingly enough, it's the same thing. So negative 3 times 2x, well, that's the same thing as 2x times negative 3. It's negative 6x. And then with our lasts, negative 3 times negative 3, we get a positive 9. The only things we can combine are the outside and insides. Now they do not cancel, but they same sign, add and keep, combine to become negative 12x. So altogether, our final answer is 4x squared minus 12x plus 9. Final answer. Now in example B, I'm going to double distribute it, but go ahead and try to double distribute on your own first and see if you can't get it from there. So if I take 3m plus p times 3m plus p, we double distribute 3m times both terms in the second set of parentheses. 3m times 3m is 9m squared, and then 3m times p, well, they have different variables, but that's okay. We just call it 3mp. We always go alphabetically, and then we'll distribute that p to everything in the second set of parentheses. Now notice we again have a 3 and an m and a p. If we keep the letters in the same order, that indicates to us, or that's easier for us to see, that we're going to be able to combine those like terms. Distribute p times p, we get p squared. And then, sure enough, like I said, we combine those, we get 6mp. So we have 9m squared plus 6mp plus that p squared. Final answer. Now in example 2, we're going in the reverse order. We're going to be factoring, and we are going to check for a GCF first, and we'll talk about what ends up happening. So for this first set, or for this first problem, I guess, we set up our parentheses, right? When we factor, we set up our parentheses because we don't have a GCF in this guy, right? Because n squared doesn't even have a number in front of it. So we just say, alrighty, I need two numbers that multiply to 36 and add to 12. Well, let's see, numbers that multiply to 36 and add to 12, we're going to use 6 and 6. Now my signs are the same. They are both minus, and minus 6 and minus 6. Now, leaving your answer like this is totally fine, totally acceptable. But know that, hey, you've got one thing written twice, right? They're matching. They do the exact same thing. You can also say, oh, you have the same thing twice. Well, that's the same thing as one set of parentheses, but squared. In example B, we do have a GCF this time around, and even if we didn't, we would want to get rid of that negative for sure. but we can take negative 3 out of everything, so that is what we shall do. So remember, with our GCF, we just set it outside, and we're left with p squared minus 12p, and then 108 divided by 3. Let's do that off to the side. 3 into 10, 3 times, we get 36. Negative divided by negative, we get a positive. And then look at that. It's almost the exact same as example A, just with different variables. Well, that's okay. So we have a negative 3, and we set up our parentheses. We have p and p, numbers that multiply to 36 and add to 12. Well, we said that's 6 and 6. Signs are the same. They are both minus. So again, leave it here if you would like. Or, how else can we rewrite it? Negative 3 times p minus 6 squared is going to be our other option. Now, our next pattern I like to call dots, which stands for difference of two squares, which we'll talk about in a second. And if we have a plus b times a minus b, so basically almost matching parentheses, well, if we were to FOIL that all out, or double distribute, whichever, so we'd have a squared, okay, negative ab, and then insides we would get a positive ab minus b squared. Now, what do you notice ends up happening? Your outside and insides cancel. So you are just left with a squared minus b squared. That's why we call it dots. Difference, subtraction, of two squares. They both have something squared. So the good news is that if you recognize that you have a dots pattern, you don't have to even bother foiling it all out. Now, it's only going to be dots when you have one that's plus, one that's minus. So if you were to double distribute or FOIL, you will get the same answer. Or you can say, okay, I have the same sets of parentheses, but 1 plus 1 minus. So I'm going to take my first thing and square it. Well, 6x times by itself, we get 36, not 12, 36x squared. And then my 7 times itself, 7 squared, I get 49. I just need to subtract in between. So 36x squared minus 49. And then in example B, same idea. We have a dots pattern because we have almost the same sets of parentheses, but we've got 1 plus 1 minus. So we take x and we square it, which is just x squared. We know we're going to have subtraction in between. And then we'll take 3y and we will square that. We'll take it times by itself. Don't forget 3 times 3 is the 9, and then y squared. A lot of people will remember the y squared, but they forget that you have to square the 3 as well. And then here is if we're going in the reverse order. So if we are using our dots pattern to factor, so to go backwards, you know that you have dots because you just have a binomial. So remember, we've said all of these tricks. If you have 4 terms, how will you factor? You'll factor by grouping. If you have 3 terms, that's when you set up your parentheses. Sometimes you have to divide inside. And up until now, if we only had 2 terms, we thought that all we could do is take out a GCF. Well, not anymore. Now, our other option, if we have 2 terms, is it might be the dots pattern. When you see that you have a binomial and it's going to be dots because you can square root both pieces, set up 2 parentheses right away. 1 is plus, 1 is minus. And then to find out what goes first, you're going to square root your first term. So whatever you get when you square root is going to go first. To find out what goes last, you're going to square root your last term. And that's going to go last in your parentheses. And then that's it. Your sets of parentheses almost look the exact same. You just have 1 that's plus, 1 that's minus. So in example 4, we know we have dots because we have A, no GCF, and B, 2 things that we can square root. So we're going to set up our parentheses, 1 plus 1 minus, and then to find out what goes first, we square root our first term. Square root of y squared is just y. To find out what goes last, we square root our last term. What is the square root of 16? It's 4. So we have y plus 4 and y minus 4, and that is our final answer. That's all we have to do. In example B, now I can't square root the things that I have yet, but what do we always look for first when we factor? A GCF. So I'm going to take out, let's see, they're both even numbers, and that's about it. So I think all I can take out is a 2 and an n. So I'll take a 2n out, and I am left with 8 divided by 2, I get a 4, minus 18 divided by 2 is 9, n cubed divided by n is n squared. So now what I have left in parentheses, that follows the dots pattern. So we have 1 plus 1 minus. We square root our first term to find out what goes first. What is the square root of 4? Is 2. We square root our last term to find out what goes last. Square root of 9 is 3. Square root of n squared is n. So our final answer with our GCF out front is 2n times 2 plus 3n and 2 minus 3n. Example 5, we're putting it all together. Now we're factoring and we are solving. So if we solve, remember we take it one step past setting up our parentheses, we set those parentheses equal to 0. So example A, we can factor just like we always have, where we set up our parentheses and we start with our variable numbers that multiply to 9 and add to 6. That's going to be 3 and 3. My signs are the same, they are both plus. P plus 3, P plus 3. Now, if from here you notice that they're the same set of parentheses, when you solve them, you're going to get the same thing. So you can really just solve one set of parentheses by setting it equal to 0. P plus 3 equals 0. Subtract 3 from both sides. P equals negative 3. That's what we're going to get from this guy too. So a lot of times what I'll do is I'll write P equals negative 3 twice, because it equals negative 3 for both of them. Then for example B, it's also going to follow the same pattern where we say, okay, 0 equals, cool. If we didn't already have 0 on one side, we would need to get 0. Don't forget that. And we'll set up our parentheses. We start with our variable. We're looking for numbers that multiply to 49 and add to 14. Well, the only really numbers that multiply to 49 are 1 and 49 and 7 and 7. My signs are the same. They are both minus. Sure enough, same set of parentheses again, so they would both end up giving me the same thing when I solve them. So x minus 7 equals 0. Add 7 to both sides. X equals positive 7. And how many times? Twice. Okay, last example. We want to find the roots. Well, remember, if you're ever asked to find the roots, you're just asked to solve. So it's like that f of x is a 0, and we have x cubed minus 81x. So we first look for a GCF, which is going to be an x. So we have that 0 over there. We took out that x. We're left with x squared minus 81. This is going to be a dots pattern for us. So everything comes along with. But our dots pattern, we have two sets of parentheses that are going to be almost the exact same, but one's going to be plus, one's going to be minus. We find out what goes first by square rooting our first term. Square root of x squared is just x. To find out what goes last, we square root our last term. Square root of 81 is 9. Now, when we solve these, we let our first set of parentheses be equal to 0. Subtract 9 from both sides. X equals negative 9. This one will not give us the same answer twice because we solve this set of parentheses by adding 9 to both sides. So x is positive 9. And whenever your GCF includes a variable, you always have 0 for one of your solutions. So as you're working through today's worksheet, I have a list of some of our perfect squares here, so you don't even have to bother square rooting on your calculator. So say you see that 81 that we were just dealing with. Well, the square root of 81 is just going to be 9. So use that as you're using your dots pattern.